How many of us are doing okay? Okay. How many of us are doing okay? Okay. How many of us are like sulking deep inside? Okay. Good to know nobody. Okay. Good morning once again. Very warm welcome to the third Transforming Education Conference for Humanity, Day 2. Today we begin with the first keynote. It's been a little late. We are expecting more people to join in, but I think the time is right for us to begin the session, otherwise we delay the entire day. So without further ado, I now call on stage Dr. Michael Whitbrock, and he's going to be talking about common sense in the age of artificial intelligence. Dr. Whitbrock has a PhD in computer science from Carnegie Mellon University. He was a principal scientist at Terra Lycos, working on integrating statistical and knowledge-based approaches to understanding web user behavior. I hope that I've got that correct. Okay, over to you, Michael.
Oh, that's a frightening picture of a much younger man, I think. Well, good morning. I'm going to talk to you a bit about, well, if this button works. Could you start the slides, please? All right. Common sense. I'm going to talk to you a little bit about AI. Many people have been talking to you about what AI is, so you may think that you've got a clear idea of what it is and where it's going and what's important in it. And I think the upshot of what I'm going to tell you is that much of that is perhaps premature. And then I'll discuss what common sense might mean and what we might want it to mean in this age of increasingly intelligent machines, and then perhaps end by thinking about what's the consequences of that for society and for human society and for education. Right, so the reason people are saying things like that this is the age of AI is perhaps because there's been a vast increase in the ability of computers to perform the sorts of skills that we perform when we're being intelligent. So and this has been really quite rapid, starting about 7 years ago. So now things which used to be very difficult, like being able to identify that that's a podium and that that's a bottle of water and that that's a glass and that that's a human being, which were very, very difficult. Well, for computers, they're now performing at a sort of level of skill which is similar to human beings. Similarly, for things like speech recognition and speech synthesis, now computer voices are extremely natural. Speech recognition is approaching or perhaps at human level, depending on what the context is. This has all happened very rapidly because we got machines which were finally fast enough to simulate the sort of action that allows human beings, the sort of neural action which allows human beings to do this. But with algorithms which are quite different and perhaps in some ways better in the way that a jet engine is better than, say, a bird flapping the wings. That's a highly controversial statement. I certainly won't say it's absolutely the case that these are better, but they're different, and they're different in ways which kind of make them quite efficient at learning to do these sorts of skills. And then a lot of these skills, and another one is like learning to play chess just by playing or Go, just by playing against yourself, right? So, and that's a particularly interesting case because chess and Go are the sorts of things which we use to tell ourselves how clever we were, right? That human beings must be better than all the other animals, cleverer than all the other animals, because look, over the course of a few thousand years we developed these games and we became very, very good at playing them, and nothing else can do anything like that, and even most humans can't do a good job of playing these games. But it turns out that in a series of kind of spectacular experiments over the last few years, we've got to the point where a computer program, a very general computer program, not even told now what the rules of these games are, right? Just being told whether they won or lost at the end right, can learn in the course of a few hours to greatly outperform all of the humans. So they're not given any of the previous games, they're not given any of the books we wrote on how clever you have to be to do this, they're not even given the rules. In the course of a few hours, they are so good that it's extremely unlikely that any human being will ever beat one of these computer programs, right? So that's kind of amazing. Another thing which is kind of amazing is this work on... No, tell this. This work on generative networks, where computers can synthesize extremely believable pictures of outdoor scenes or people's voices. This, I think, computers end up doing better than we could have expected. Many of these things, sort of looking back to the 1980s and the 1990s when we were working on the early stages of these things, we could have predicted. I think generative, these image synthesis and voice and story synthesis and so on, we really probably couldn't have predicted. And the reason I'm telling you about these last two things is because what it indicates, to me at least, is that we don't know how difficult intelligence is, and we do quite a bad job of judging that. Right, so what is artificial intelligence? You might think this artificial intelligence thing is recent, right? That it's something that humans have come up with in the last, maybe 7 years if you've been watching the hype, or 100 years at most, or maybe a couple of 100 years because the Victorians were starting to think about this stuff, but it's really much older than that in a sense. So there's kind of two threads of artificial intelligence. On the left, I would say that artificial intelligence is the process of trying to characterize what thought is. More precisely, it's us trying to understand what thought is by virtue of working out how it could be implemented on something which isn't us. So in a way, I think that sort of the first book on artificial intelligence was probably the organon by other people assembled out of Aristotle's work. So that's 2,500 years ago. People were already trying to think of what's this thing that humans do which is special, which allows us to control our environment, allows us to transmit information over time, allows us to have cultures. And then one approach to that is to work out, all right, how can we simplify thought down to its most basic principles and see sort of what breaks. How can we abstract it as much as possible? So this has actually driven a thread of artificial intelligence, and it's also driven threads of sort of trivializing philosophy like trolley problems, but we'll put that aside. So this thread has kind of led to Babbage trying to work out, okay, what's a general way that we can implement the sort of things that mathematicians do. So that's either a piece of the analytical engine or a piece of the difference engine. So that's almost 200 years ago. The first attempts to actually build things which could do something like general thought were made. Then in the 1950s, there were things where you could type at them and they would move things around, so they kind of very dimly understood language. Then in the 1980s, early 1990s, there were the first computers which became seriously good at chess in that they could beat humans at some games, and there were also computers which could answer questions and give you an explanation of why that answer was that answer. Right, so that's one thread of AI. And up until, I'd say, quite recently, up until the 21st century, that thread of AI was kind of the most notable thread, the most successful thread. It's not that the other threads weren't going on, but if you talked about AI, you would have been talking about that. On the other side is a completely different thread. It's not quite as old. This picture here is a little over 100 years old. It's a guy called Santiago Ramon y Cajal, who produced for us the first really good pictures of what was inside our brains, and supported sort of the theory that this was what gave us intelligence, right? And then starting from that principle that it was these neural networks, these networks of cells, which were the computational basis for our intelligence, people tried to replicate this. So they give up on this point. That machine there, with all the wires, is something called a perceptron. Probably from the 1950s, but for a very small perhaps error, something that was overlooked, that could have triggered the sort of current fashion for neural networks. Apart from our computers were ridiculously slow back then, so they wouldn't have been very good neural networks. Down at the bottom there is something called AlexNet. That was kind of the first neural network which vastly outperformed the manually produced programs for computer vision. So it, in one fell swoop, it knocked 15% off the error rate for computer vision, which had been stagnant for a long time. And it because we had the existing research on neural networks and GPUs, that was able to kick off the acceleration we have at the moment. So this is this stuff on the right is kind of why we think we're in the age of AI at the moment, but that might be a kind of mistaken point of view. Yesterday, you were told about System 1 and System 2, and possibly a System 3, these two types of thought, right? So what we are in at the moment is the age of System 1, in a sense, right? We are now able to build machines which replicate the sort of skills that all animals have, right? So being able to quickly recognize that there is 20 minutes left. So I'm not going to overrun. Skills which are frequent, automatic. I don't have to think about how to recognize that there's a woman, two little girls and a boy, probably, in the front row here. It just happens automatically. In fact, I have to deliberately override biases that might result from the processing of this sort of processing. It's unconscious, it's stereotyped, it's invariant, and it's sometimes directly connected to emotional. But though System 1, that's not why the human beings are in charge of this planet, right? The reason why, for better or worse, all the other animals kind of depend on our kindness for their livelihoods is because of the System 2, reasoning. Right? And that is a very unusual kind of skill. The kinds of things which have it are, to some degree, are able to be enumerated on the right. And this is, it's really slow. When we're trying to think carefully about things, it's really slow and it's difficult. It doesn't happen very often. We actually have to monitor our own operations to make sure that they don't go awry. This is like peculiar, right? I mean, it requires conscious control, but it's compositional and it's flexible, and it's not really subject for its operation to how we feel or who we are. And these together make it very powerful. Just as an aside, that thing at the bottom is a New Zealand parrot called a Kia. They're very smart, and it's disassembling a human car. So it's quite possible, in my view, that Kia's noticed that human beings arrived in Aotearoa, New Zealand, about 1,000 years ago, and they're still annoyed about it. And perhaps they hate us enough to disassemble our cars. We'll see. All right. Not only are there kind of two types of intelligence, but there are also two types of learning. There's skill learning, and that's what's all the sort of enthusiasm's about at the moment. But it's the sort of thing that when we do it, or when neural networks do it, requires training. It requires many examples, and transfer to new tasks is limited. And when you learn to do one of these tasks, you perform them. You don't kind of use them in more complex ways. And that machine learning, big data, and computation have given us the ability to have computers do those, right? But notice that this requiring many examples, for example, this big data thing is only true of that kind of learning, the kind which is currently successful. There's another kind of learning, and the learning that we're mostly talking about when we talk about education, right? And that's learning with knowledge. This can be done by instruction, right? You tell someone what the piece of knowledge is, they listen to it, and somehow it goes into their brain in a way that they can use it again. It can be acquired in a what we call a modality-independent way. Doesn't matter whether you read it, you listen to it, you watch someone doing something, you look at something, for example, on television, you acquire more or less the same knowledge and can reuse it in more or less the same ways. That's very odd. And it can be reused widely. You can apply it to new problems, and it can be reasoned with. And I'll dig down a little bit in what reasoned with might mean. Right, so the fundamental reason why we're in charge is that we can do this and other animals can't do it or can't do it well at all. We can break down problems, solve them, and reassemble the answers, right? So we interpret a problem to be solved, we transform it into a set of simpler problems. Perhaps we distribute those problems to lots of people, right? We solve those problems, we look at the answers, and then we use those answers to assemble a solution to the whole problem. That's a very difficult thing to do, right? Other animals don't do it very much at all. You know, an octopus can do it. Sometimes crows do it with like sticks and so on, but not in very general ways. We do it really well, or at least we think we do, because nothing else can do it, right? Turned out we were no good at chess. We might be no good at this either, just better than everything else. Right, so just to give you an example, you know, suppose we want to work out whether Visakapatnam is a city, right? I said we break down the problem, right? So there's two different ways of solving this. If either of them are true, then it's a city. It's a city if it's the capital of a country. Is it the capital of a country? Well, I looked on, I'm no expert in Indian history, but I did do some research on the internet, and I can find no evidence that Visakapatnam was ever the capital of anything. It had all sorts of interesting history, but probably not. And it's certainly not the capital of a country now. And if it tried to be, those ships which are cruising up and down the harbour might have something to say about it, right? So we give up on that. We failed, right? Nope. The alternative is it's a city if it has more than 70,000 inhabitants. And we can find out the answer to that by finding out the number of inhabitants of the city and working out whether that's greater than 70,000. See, this breakdown is like kind of weird and trivial, right? It turns out that there are 20.4 lakhs of people in this city. That turns out to be quite significantly more than 70,000. So using my purely arbitrary Michael criterion for a city, this city, and assembling those together through the green arrows, we can conclude that it's a city, right? So that's kind of trivial, right? But actually, I think that we would do well to teach kids that this is what they are doing when they solve problems and when they do math. That this is a general class of things that humans are very good at, right? So, skip that. Now, that sort of reasoning, we don't do it in logic. That was a kind of logic. And when we can do things in logic, we do it very well, right? So when we can do that sort of reasoning in mathematics, it's completely reliable. But most of our reasoning isn't like this. And this is why I think we should be teaching kids that this is what they're doing, because we do this in a lot of different contexts. We do this reasoning operation over a lot of different types of knowledge. So, for example, and we design types of knowledge to facilitate this reasoning and to facilitate it being either more flexible or more accurate. Right, so the thing I showed you there was a kind of Englishified mathematical logic. Now that's great. When we can do it, it's extremely reliable, and we know exactly how to have computers run, do inference over mathematical logic. Similarly, computer programs are a kind of knowledge representation, which again, if you feed them into a computer, you get completely reliable results, right? But there are other things which are kind of different from that, right? So careful legal language, for example, the language in which we do legal thought is not very expressive. There are many things that you can't really say very clearly in legal language, but when you say something in legal language, people will agree on it, right? So it's English or Hindi or Chinese or another language optimized so that people will agree with the conclusions that you can reach. And I think understanding that about language is a very powerful thing, again, that perhaps we should teach kids about. And then we have these more expressive but less reliably reasoned about representations like informal narrative, fiction, and poetry and song, where we can express almost anything, but the chances that other people will draw the same conclusion from them are low. And in fact, part of the point of them is that other people will interpret them in multiple ways. But it's all the same process. It's all the same process of taking knowledge and applying it to the interpretation of new things. And I talked mostly about text, but this continuum of types of knowledge where they're optimized for either reliability or expressiveness applies widely. So, given that, what's common sense? Well, common sense is a kind of knowledge somewhere along this continuum. NYU's Ernie Davis says that it's roughly what a 7-year-old knows about the world, right? The fact that if I move here, I should start getting worried, right? In fact, because I might fall off, right? The fact that the people in that row are farther away from me than the people in this row, all sorts of things like that, right? So that's common sense knowledge. And there's been a kind of industry of people saying it's really important for computers to have common sense knowledge. I think that deserves to be thought about. And actually, the desirability of common sense knowledge in humans needs to be thought about too. It's a fact that we have it, but is it an unallied good? I'm not sure. So in AI, an example, a way that we test for common sense knowledge is something called the Winograd schema, right? So it's sentences like this. So the members of the council, sorry, this is an old sentence and it's sexist, but the members of the council refused the demonstrators a permit because they feared or advocated violence. And depending on whether we put feared or advocated there, the they either refers to the members of the council or to the demonstrators, right? So this is called the antecedent of the they changes depending on whether it's feared or advocated. Now, so that's sort of interesting. We need to do that sort of thing all the time, right? Our knowledge of what feared means and our knowledge of what advocated means, our common sense knowledge of those, determines how we understand this English sentence, right? So we clearly need common sense knowledge. But, so it's necessary, right? The question is it sufficient to building the kind of AI systems which are really going to be good for human civilization? And is it appropriate for computer systems to have the same kind of common sense knowledge that human beings do? And I think those are kind of interesting questions, and particularly appropriate, right? So when people talk about algorithmic bias, right? When they talk about algorithms which are sexist or racist or classist, what they're really talking about is human common sense knowledge being manifested in the data that's used to train these things and being incorporated in their operations. So do we really want human common sense knowledge, the sort of knowledge, for example, that so not to put too fine a point on it, but in this conference itself has suffused people's discussion of the roles of mothers and families in education. That's common sense, but it's also deeply sexist, that discussion. And I think that's also so interesting. Common sense knowledge is also simplifying. Right? It's facts about the world, observations about the world, even correlations in the world, reduced to simple things that human beings can understand and talk about. But the world's, in fact, extremely complicated. Right? One of the things which goes badly wrong in our civilization is people taking complicated situations and reducing them to simple interpretations that they then compose by reasoning and reach just wrong and sometimes tragically wrong and harmful conclusions. So, if we could avoid that in ourselves, wouldn't we do it? Wouldn't we choose perhaps to have less common sense and more complexity? So one thing that I really think is that with AI systems, which might quite rapidly become, or quite slowly, we don't know because we don't know how hard thinking is, right? They might become quite good at this sort of rational thought that has advantaged human beings, but in ways that we can't achieve, right? In ways which don't require as much simplification, in ways which recognize the true complexity in the world. We may be able to share the way we think about the world with these systems and mitigate our own biases, right? So I do think that, I talked about these two threads of AI, right? The ones where skill learning at the moment, which has been so very successful, the other historical thread of AI, which has been recently less successful, but is, I think, very likely to be accelerated in the next few years by applying the techniques which have been so successful for skills. And since we don't know how hard it is to do that kind of thinking, we just know that it's really hard for us and that we're really proud of ourselves when we can do it. But as we learn from chess and Go, that's not a good indicator, right? So it may be hard, it may not be. We may be able to do these things quite soon, right? And it can be a very useful tool for understanding the actual complexity of the world without having to simplify it. So I think what it means for the world is that we might have tools that allow us to understand the world, right? In the same way that libraries helped us to understand the world by allowing us to store knowledge over time. These systems which can think about complex systems, which may be able to think about complex systems in all their complexity, could be vastly useful to us. And then what does it, suppose we have these systems in the world with us, what does that mean for our civilization and for the role of humans in it? Right, so I'm almost wrapping up. And I'll give a couple of examples of where that might lead us. Right, so as I said, one of the things which made us as a species really successful is the ability to write and read, and the ability to write and read on things which lasted a long time. So a small library by modern standards, the part of the National Institutes of Health in the United States, there's a thing called PubMed Central. It has 5.8 million scientific papers in it, right? So if I didn't sleep, which is difficult for humans, and I could pay concentrated attention for long periods of time, which is even more difficult for humans, then it would take me about 1,000 years of continuous reading in order to read all of these papers. This relatively small fraction of our scientific literature. And suppose that there's a fact in one paper in these 5.8 millions and in another paper in these 5.8 millions, which together constitute a significant step towards, say, a cure for cancer or anything that you, any overly simplified thing that you as a human being might desire, right? I'm not going to come across it. And the likelihood that a single human is going to read both those papers is also quite low. But computers don't have to be like us, right? They have advantages in these things in white. They have advantages in complexity, right? They can pay attention to many more things at once for some sense of paying attention. They have bandwidth. As a human being, I'm talking to you at an effective bandwidth of, something like a modem from the 1980s, right? A few kilobits per second. All of the humans speaking simultaneously, if we did that, all of our communication would fit down one fiber of not even our best fiber optics, right, at the moment. So our bandwidth is terrible. Computers can communicate with each other very fast, which means that they can put these papers together. We have limited accurate memory. That's why we build libraries. Computers don't. Right? We have limited attention. Human beings, for all they talk about multitasking, that's by analogy with computers, and we simply can't do it. Right? We like to talk about what neuroscience tells us. What neuroscience tells us is that human beings have one thread of attention. Doesn't mean we don't do parallel processing. We do when I'm recognizing that that's a chair. It's highly parallel and extremely fast. But for attention, we have one thread of attention, and that's it. And if you think that's not true, you're going to kill yourself by playing with your cell phone while you're trying to drive, because you can't do that, right? Computers have higher precision, they have more parallelism. So a lot of this complexity of our civilization, we like to think it's simple. We like to tell ourselves that it can become simple enough for us to understand it. That's simply not true, but now we have an opportunity to build tools that we can delegate that complexity to. And these things at the bottom are sort of positive outcomes of being able to share that complexity. So what's the role for... So if we're going to have computers take on this role for us, what's the role for us? Because if you think about even halfway decent robots and computers which can take on that complexity and can do both the skills and the kind of reasoning that humans do, it's very hard to see humans continuing to be used, right? When people talk about employing a human, they think about what that means. It means you're using that human being as a tool, in much the same way as that you might employ a shovel, right? That's not inherently a good thing, right? We might think it's a good thing, but suppose that all of those things that we use humans for can now be done by machines. What's the role of humans? So we heard about teaching people training for well-being, right? Can we be trained to nurture other humans? Can we be trained to care about, to have a stewardship of our planet in a way that only humans can or only humans should, right? We should think very hard about what are the things which humans should do, how we should behave to each other, what sort of civilization we want to have. And I think because we don't know how soon these changes will start kicking in, we really need to start thinking about that now, and we need to start educating our children with the flexibility to be useful if we still have to be useful, but to be good and valued humans in every circumstance where we can afford that to them. And that is a very different kind of common sense. Thank you.
We have one
Arguments are
question
something that humans
on
do
my
well.
left.
Aren't you jumping the gun a little bit when you're saying that common sense is not needed? Because when we have...
I didn't say that. I
Okay.
said, in fact, that common sense is necessary,
Yes.
but that it's not sufficient, and in many ways it's dangerous. But it's clearly needed.
So what I mean is that when we're placing our lives in the sort of care of decisions made by AI, we would dream of it having common sense, right? And in
No.
order to do that properly, and then once we have that, of course, then we could dream of having something else. So just to make that clear.
So I don't think that's true at all. So I think that common sense is this reductionist thing, right? It's something that we use to explain how we came to conclusions for other people. And how we explain how we came to conclusions has very little to do with how we actually came to conclusions or how we actually decided to act, right? Human beings have this tremendous skill of confabulation. We construct an argument that we think will convince other people to go along with what we did. That skill is being used to tremendously harmful effect in the world at the moment, right? People are making explanations which seem commonsensical for why they should discriminate against people, for why they should admit to one class of people and not another class of people to important roles, for why medical decisions which may have been made on, say, the basis of prejudice, or imprisonment decisions making far better decisions and building a far better civilization for us, our descendants, and the animals and the planet that are in our care. So I quite thoroughly disagree.
Your wonderful presentation. May I remind you that we have AMAs at the end of the day for you to have a one-on-one, longer conversation with the speakers. So please hold your questions for now. Now it's my privilege to invite Mr. John to tell us how the compassion game shaped up yesterday and give us some stats and tell us more about how the game is rolling in the conference. John?
All right. Thank you, Michael, for that. In fact, the presentation is a good segue. You know, we said we want to shift from transmissive pedagogies to transformative. The difference between problem solving and problem setting. I've been transformed by playing that game yesterday with the youth. And I hope that you're playing, and I want to encourage you to do it. For instance, I learned how limiting the caste system is here in India. And if we're going to make change, here we are talking about the power of education to transform, but yet the systems that we're operating in are constraining us in profound ways. So I'm humbled and grateful to everyone who played. And I want to encourage those who were frustrated and couldn't get it. In fact, I learned a few things. On the Android app, you have to click on schedule again, but the compassion games, all the missions are there. And a number of people suggested it would have been good if we could take time to actually experience, for instance, the first mission, befriend the other, bridging our differences, especially engaging with people that are not the typical people we'd approach. It transformed me. I know it will do that for you. I heard that from so many people. What it's like to have the generative and strategic conversations, the kind that build trust. As you listen to somebody and maybe don't understand them, what does it mean to say, okay, wait, go slow. I want to hear what you have to say. What is it to give each other the gift of presence, to learn and discover what's possible? And hopefully that mission will evolve to us building this map so we can see who are all the players in the world of social and emotional learning. And how can we begin to take on the task together? Because I came to this conference not just to have a standalone one-time experience. We're planning to convene again online on January 27th to build upon the momentum that we create here to mainstream social emotional learning at a critical time in our world's situation right now. That's mission 2, better together, cooperating for the common good. And then last night we lit the torch. And tonight we're going to celebrate our cultural differences, our shared humanity. And I'd love you to share your fire with the world. Tell the world what you're grateful for, what's your wish for the world, and see that global fire of our common expression of what we're up to. The 4th mission, mutual mentors. What is it to go and listen, to discover what is our common values? What are our shared interests? What are you doing? What am I doing? Are you interested in what I'm doing? Am I interested in what you're doing? What are our unique resources? How can we combine those resources to turn what we have into what we need? With whatever breaths are left in my life, I'm determined to have our generation make a difference, to make sure that this next generation is empowered in ways that they're struggling with. They're looking at problems that we ourselves don't understand. We've got to do this together as mutual mentors. We have so much to learn. I learned so much from the youth yesterday. The gender inequality. Here we are telling them about the power of these technologies when social systems are constraining them. We can't let that just go by the wayside. It is an intergenerational equity. It's our responsibility to make sure that they're prepared to take on these challenges. And I love the fact that a game is actually demonstrating that. I invite you to come at 5 o'clock today in V3, we're going to follow up this conversation. I have so much more to share with you about what's unfolding in this alliance we're building to learn how to synergize, to turn what we have into what we need together. So it is with profound humility and gratitude. I want to thank everyone who's been willing to open up and try to play. And we have now many, many pictures of people befriending each other. We've been growing the map. We have this time together. Let's not waste it. I'm grateful for you coming up to me. I want to know you. I want to see how we can work together. So what else have I missed? Somebody's sitting on a question or something that's burning. All right. Game on. Game 2, day 2 continues. All right.
So we have a break for 15 minutes and then we convene for the catalytic session. So you can go for the break. Thank you.